My name is Arnav Chantala, and I'll be presenting Chapter 9.3, The Synthesis of Aldehydes and Ketones. This section of the chapter covers the chemical reactions that represent the preparation of aldehydes and ketones. The types of reaction included are the oxidations of first and second degree alcohols, the hydration of a terminal alkyne, and the Friedel-Crafts acylation of an aromatic ring. Regarding the first reaction of the oxidation of first-degree alcohols, primary alcohols are oxidized to only give aldehydes. These reactions typically use pyridium chlorochromate, otherwise known as PCC. In the reaction below, citronellol is synthesized into citronellol using PCC. The functional group of the alcohol in citronellol is synthesized into the functional group of aldehyde, the CHO group in citronellol. Another example for this oxidation reaction is the synthesis of formaldehyde from methanol, which is catalyzed by silver. This reaction is done on an industrial scale to synthesize formaldehyde. However, you cannot synthesize casualdehyde, as it is not an actual compound. The second reaction is the oxidation of the second-degree alcohols. Secondary alcohols are oxidized to only give ketones. These reactions typically use pyridium chlorochromate, PCC, chromium trioxide, and sodium dichromate. In the reaction below, 4-tert-butyl cyclohexanol is synthesized using PCC into 4-tert-butyl cyclohexanone 1. The bond between the carbon and the alcohol functional group in 4-tert-butyl cyclohexanol is transformed into the double bond between carbon and oxygen that's found in ketones. So regarding the mechanism for both oxidation reactions, the hydroxy hydrogen of the alcohol is replaced by the leaving group. The base can abstract the proton bounded to the alcohol carbon. Thus, the leaving group X is eliminated, and a new carbon-oxygen double bond is formed. Below shows a mechanism of the oxidation of second-degree alcohols, and the only difference between first-degree and second-degree alcohols are that the carbons in secondary alcohols are bonded by 2 functional groups, and primary alcohols, the carbons are bonded by only 1 functional group and 2 hydrogen atoms. The third reaction is the hydration of an alkyne. The hydration of a terminal alkyne yields a methyl ketone. Markovnikov addition of a hydroxyl group to an alkyne forms a ketone. Markovnikov's rule is that hydrogen adds to the less highly substituted carbon. In the reaction below, hex-1-ine is synthesized into hexane 2-1 using hydronium. The triple bond breaks into a single bond between the carbons, and a double bond forms between the carbon and the newly added oxygen. And the hydrogen from the hydronium goes to the CH on the right side of the equation because it's the less substituted carbon. The last reaction is the Friedel-Crafts acylation. The Friedel-Crafts acylation of an aromatic ring yields an alkyl aryl ketone. When an aromatic compound is treated with functional group with carbon, oxygen, and chlorine in the presence of an aluminum chloride, an acyl group, which is carbon, oxygen, and another functional group, is introduced into the ring. In the reaction below, benzene is added to acetyl chloride, which is synthesized into acetophenone. Regarding the mechanism for this reaction, the formation of a complex between the Lewis acid and the chlorine atom of the acid chloride. An acylium ion is formed by the cleavage of the carbon and chlorine bond of the complex. The acylium ion has a positive charge on the carbon and is resonance stabilized. This psyllium ion acts as an electrophile and reacts with the arene to yield the aryl ketone. Thank you for listening.